We want to solve the given one-step equations. First equation is negative 9/4 equals x divided by 16. The solution to the equation is a value of x that satisfies the equation or makes the equation true. And in order to solve the equation, we need to isolate the variable on one side of the equation. Looking at the right side of the equation, notice how we have x divided by 16. And therefore, to isolate the variable, we need to undo this division by performing the opposite or inverse operation to both sides of the equation. Well, the opposite operation of dividing by 16 is multiplying by 16, and therefore to solve, we multiply both sides of the equation by 16. So we multiply the right side by 16 and the left side by 16. Let's begin by simplifying the right side. We can write 16 as 16 over 1. And notice we can simplify before multiplying. The numerator and denominator have a common factor of 16. There's 1, 16, and 16 here as well as here. Notice now the product is just x times 1, which equals x. So the right side simplifies to x, and now let's simplify the left side. Again, let's write 16 as 16 over 1. Let's simplify before multiplying. 4 and 16 share a common factor of 4. There's 1 4 and 4, and 4 4s and 16. The product is now just negative 9 times 4, which equals negative 36. So our solution is x equals negative 36, which can be written like this, or in the opposite direction as x equals negative 36, which is more common. But either is acceptable. Now let's verify the solution by verifying x equals negative 36 does satisfy the divisional equation. So we'll substitute negative 36 for x into the divisional equation, which will give us negative 9/4 equals negative 36 over 16. Let's simplify the fraction on the right. 36 and 16 share a common factor of 4. So let's divide the numerator and denominator by 4. So we have negative 9/4 equals negative 36 divided by 4 is equal to negative 9. 16 divided by 4 is equal to 4. And notice how we have negative 9/4 equals negative 9/4, which is true, verifying the solution is correct. And now let's look at the second equation. We have negative 7/8 equals negative 3/2 x. Again, the solution is a value of x that satisfies the equation or makes the equation true. In order to solve, we need to isolate the variable. Looking at the right side of the equation, we have negative 3/2 x, which means negative 3/2 times x. So we're probably thinking in order to isolate the variable, we need to undo this multiplication by dividing both sides by negative 3/2. But remember, instead of dividing by a fraction, we normally multiply by the reciprocal. So instead of dividing both sides by negative 3/2, let's multiply both sides by the reciprocal, which would be negative 2/3. So we'll multiply the right side by negative 2/3 and the left side by negative 2/3. Let's simplify the right side first. Negative 2/3 times negative 3/2 is equal to 1 because they're reciprocals. Or if we simplify, there's 1, 2, and 2 here and here. There's 1, 3, and 3 here and here, which gives us negative 1 times negative 1, which is 1. 1 times x is x. On the left, let's simplify before multiplying. 2 and 8 share a common factor of 2. There's 1, 2, and 2, and 4 2s and 8. Multiplying, we have negative 1 times negative 7 in the numerator, which is positive 7. In the denominator, we have 3 times 4, which equals 12. So the solution is x equals 7/12, written like this, or in the opposite order of x equals 7/12. Again, either is acceptable. Now let's check our solution by substituting 7/12 back into the original equation. Performing this substitution, we'd have negative 7/8 equals negative 3/2 times 7/12. On the left, we have negative 7/8. Let's simplify here before multiplying. 3 and 12 share a common factor of 3. There's 1 3 and 3, and 4 3s and 12. And now we multiply. In the numerator, we have negative 1 times 7, that's negative 7. In the denominator, we have 2 times 4, which equals 8. We have negative 7/8 equals negative 7/8, which is true. Again, verifying the solution is correct. I hope you found this helpful.